Okay, if you have your sheet that you picked up from last week, you can follow along and take notes. If not, just pay attention and write down whatever you feel you need to. The first question is, if given the equation x squared equals 9, what can x equal? Many of you might think it's just 3 because 3 squared equals 9, but in actuality, um, we know that 3 times 3 equals 9, but negative 3 times negative 3 also equals 9. So we have two solutions. We have positive 3 and negative 3. Instead of writing x equals 3 and x equals negative 3, we could actually write the solution like this. X equals plus and minus 3, which means positive 3 and negative 3. So written at once. So what I'm going to try and have you guys do is this. If you were to look at this equation, if we take the left-hand side and graph it, and take the right-hand side and graph it, for example, y equals x squared is the red graph, and the line y equals 9 is the blue graph. And if we look at where they intersect, where are they intersecting at what x values? They're intersecting when x equals positive 3 and negative 3, which goes to prove that there are two solutions for when x squared, or the parabola, equals this horizontal line y equals 9. So negative 3 and positive 3. But again, this is completely acceptable and almost expected in how you write the answer. So what I want you to do here is to see this graph and what equation could have been used to solve this graph. So this graph is, the red graph is y equals x squared. I want you to think of what the equation would be for the blue graph. Okay, so it's not going through 9 any longer, but it's going through the number 6. So it is crossing over y equals 6. So the equation that could be used to solve this inequality, the system, would be x squared equals 6. So when is x squared equals 6? What I'd like you to do is to use the graph to estimate the two x values. Okay, so let's see where it is intersecting. Now it's not intersecting at any particular clear number, whole number, but it's somewhere between 2 and 3 and negative 2 and negative 3. So I would say maybe negative 2.5 and positive 2.5. Or we could say plus or minus 2.5. So in order to solve this algebraically, what would we have to do to both sides? We have to get rid of the x squared. Okay, so we can do that by taking the square root of both sides. The key, however, is that when we take the square root of both sides, it's not just the square root of 6, it's plus and minus the square root of 6. So to solve algebraically, we have to square root both sides and then put a plus and minus in front. So for example, we're going to have x equals plus and minus square root of 6. I'm just going to bring up my calculator for a second. Here we go. I'm going to put in the square root of 6. So I'm first going to press 6 and then square root. And as you can see, the answer, if we were to round it, would be 2.45. Okay, 2.45 is fairly close to 2.5. So we can say now that the x values are roughly around plus and minus 2.45. Okay, this would actually be the exact answer, and this is a rounded answer. Okay, so let's go to this more challenging one. This x squared graph is no longer hitting the vertex at 0, 0. It has been shifted up. So there's a vertical shift, and we have a new horizontal line going through a new number. So how many spaces has the parabola gone up? It looks like it has gone up 1, 2, 3, 4 spaces. So that looks like it's x squared plus 4. And the blue line is going through the number 8. So this is when is x squared plus 4 equal to 8? If we look at the graph, we could see that the answers are very clear. They're intersecting at whole numbers. So they are intersecting at 2 and at negative 2. And we could quickly check that. 2 squared is 4 plus 4 equals 8. And negative 2 times negative 2 is 4 plus 4 equals 8. But how do we solve this algebraically? Well, I've got to isolate x, so we need to get rid of this 4 as well as the x squared, or the squared. So the first step would be to subtract 4 on both sides. So what do we have? We have x squared. If we subtract 4 from both sides, we would have x squared equals 4. And then, to get rid of the square, we are simply going to square root both sides and put a plus and minus in front, which would mean we would have x equals plus and minus square root of 4, which is 2, plus and minus 2. And those are the answers we get from the graph, positive 2 and negative 2. Okay? So you have a test question just like this. When is x squared plus 4 equals to some number? You basically need to know how to get the steps, but also consider how you could get the answer graphically. All right, we're going to move on to what we call connecting representations. This is not on the handout. What I'm giving you is 4 graphs, and now I'm only going to give you 3 equations. And I want us to match the graphs with the equations. So I'm going to call this graph A, this graph B, this graph C, and this graph D. Okay? One of these graphs stands out from the rest. And why don't you take a guess at what that is? And just remember, at any point, if you need to pause the video and rewatch, that's the beauty of videos, you can do that. So the graph to me that stands out is the red one, because it is the only one that is facing downward. Okay, so looking at these 3 equations, of the 3 equations, which ones would that match? So if you said h of x because of this negative in front, you are correct. So this is the h equation. And furthermore, we could check this because this number at the end is the y-intercept, the plus 3. So I could check, yep, that is hitting the y-axis at positive 3. H of x is in standard form. So if you want to now look at f of x, that also is in standard form. So if this positive 3 is the y-intercept, this negative 3 is also a y-intercept. So that is negative 6. This might be something like 7. And then if we look at this one, this is hitting at negative 3. So it looks like C is equation F. All right, we have 2 graphs remaining with 1 equation remaining. So let's analyze what g of x is. G of x is actually in factored form. So the factored form gives us the roots, but the roots are not positive 3 and negative 2. We actually have to change the signs. So the x would have to equal, looks like negative 3, we have to change the signs, and positive 2. So I'm just kind of writing it like that. Or the points negative 3, 0, and 2, 0. If you look at graph D, these are hitting at both positive values, and it is clear that one has to be negative and one positive. Therefore, there's your positive 2 and your negative 3. So this is the graph of G. Lastly, D. We can now write the equation for D. Okay, so we could do it in one of 2 ways. One is, seeing that we have the roots are 2 and 4, we could go ahead and write it, I believe this is m of x, okay? We could go ahead and write it looking like factored form, okay? So because the roots are positive 2 and positive 4, we would write x minus 2 and x minus 4. So this is one way of writing the equation. Or the other way is by the vertex. The vertex is positive 3, negative 1. So let's look at this. This would be vertex form. X minus 3 squared minus 1. Change the sign, keep the sign. Okay, so lastly, in the last 5 minutes, I want to quickly explain this. We have 4 equations, 4 graphs. We have to match them. Okay? All of the equations look very similar. So we have to look at the key features that each of these equations gives us. Okay? So if you look at equation A, and that's it. This is the only one in standard form. This would be the y-intercept of positive 8. That could be here. That could be here. That could be here. It's definitely not here. That's negative. So what I would start with is which graph stands out as being different. I would say graph 2 stands out as being different because it's also the negative graph. So it's downward facing. So if we look at D, there's our negative. Okay, so that is D. I would then maybe look at C. C is vertex form. What do we have with the -6? We would have to change signs and keep signs. So 6, 8 would be the vertex. So that would mean quadrant 1. Here the vertex is not in quadrant 1. The vertex is not in quadrant 1. The vertex is not in quadrant 1. But here the vertex is in quadrant 1. So that would actually make point P be the vertex, which is 6, 8. Okay, so C goes here. If we want to go back to D, we have to find point Q. If you look at this form, this is actually factored form, which makes it figure out the roots. So the roots would actually be, or the zeros, when x equals -8 and +6. Okay, so this must be the +6, and this must be the -8. So the coordinates for Q must be -8, 0. So that would be the coordinates for Q. Finding R and S is going to be more difficult, but first let's match the equations. If we look at B and we look at A, okay, I think we already distinguished A to be the y-intercept is +8. Here it's negative, here it must be positive. So this has to be A by process of elimination. And in B, this is also in factored form, so we could get the roots. So we have the roots of +6 and -8. Okay, so that is +6 and -8 right here and right here. Okay, so this must be B. Okay, in the last 2 minutes, I'll just quickly talk about how to find R and S. S is a little bit easier. Okay, for S, what I would say, it's the y-intercept, which means the x value is 0. So if you look at this equation, I want to plug in 0 for x, so I'd have 0 minus 6 and 0 plus 8. So I have that here. Okay, so if I plug in 0 for x and 0 for 8, 0 minus 6 is -6, and 0 plus 8 is 8. So -6 times 8 is -48. So S actually has the coordinates of 0, -48. It's a little deceiving because it's not to scale. For equation A, if you look at it, it's in standard form. R is on the x-axis, which means the y value is 0. So let's just take a look. So basically, I just started plugging in numbers. We're going to learn how to factor and get those answers easily in the next unit, but I need to know when the y value is 0. So I'm looking here where the y value is 0. When I plug in 2, I actually get 0, and when I plug in 4, I get 0. So the first number is 2, which is here, so R must be 4. So the coordinates for R are 4, 0. Okay, so that is it. This is your review for your test and our activity for activity for Tuesday and Wednesday. Okay, so please come to tutoring. There will be laptops in tutoring to make up any homework and to prepare for Thursday and Friday's test. Great.